So today we are going to discuss about the second part of the video, that is the moment of inertia of the disk and how to apply the applications in other objects like sphere and cylinder. In the first part of the video we have seen how parallel axis and perpendicular axis theorems are helpful in measuring the moment of inertia of ring at different points. So let us start for the disk. Now, the major difference between a disk and a ring is that the ring is like a bangle while the disk is like a plate. So both are differ from each other. The moment of inertia obviously will be different because it is totally solid, it is 2D solid. In case of a moment disk, we can find out the formula which can be derived out, and formula is coming out to be half of mr square. And then we can find out the moment of inertia of a disk about tangent parallel to the plane and how the parallel axis theorem can be used. And or through the diameter, we can find out the perpendicular axis theorem. For example, again we can draw the two diameters along x-axis, along y-axis, and z-axis are there. So perpendicular axis theorem says I is diameter, the moment of inertia along z-axis is equal to moment of inertia along x-axis plus moment of inertia along y-axis. So it can be written as id plus id, that is equal to half mr square. So that means 2id is equal to half mr square. So that means id will be equal to 1 by 4 mr square. So that means the moment of inertia of a disk along any diameter is equal to 1 by 4 of mr square. So that is, here we have taken the help of perpendicular axis theorem. Now we can find out the moment of inertia perpendicular to perpendicular to its plane, and that we can able to find out perpendicular tangent to its plane. So that can be find out. Let us say this one, this is your diameter, and let us say AB about any of the diameter. This is your x-axis and y-axis. Now we have to find out the moment of inertia along xy line. So that will be equal to moment of inertia of AB plus let us say the distance between them is r, so that is plus mr square, mr square. So moment of inertia along AB we have already known what is half mr square plus mr square. So that means 3 by 2 mr square. So that is the moment of inertia of a disk parallel to the tangent to the axis of the body. So is like this one. So this is a body, so we can draw the tangent. So this is the center where we can draw, this is the tangent. Second is the body where this kind of axis is the diameter, and second tangent could be drawn to this one. So this is a case when the axis is passing through the center and tangent drawn over here. So in that case the formula comes out to be about 3 by 2 mr square. Now we are going to discuss the second case when the axis is the central axis, the diameter, any of the diameter, either this or this, and tangent is drawn along this axis. So we can draw the diagram for that also. So that is equal to this one. This is the diagram for this. Let us say this is the diameter, and we are going to draw the tangent along this axis. Now let us say x, y, now b, b dash. So the moment of inertia along b, b dash will be equal to I x, y plus m r square. Why mr square? Because r is the distance between these two, and m is the mass of the disk. And so this is, so moment of inertia about any diameter we have already find out, it is 1 by 4 mr square plus mr square. So now the moment of inertia comes out to be 5 by 4 mr square. So this was about the using parallel axis theorem we had measured it out. So that means we have seen that in case of ring, in case of disk, how the parallel axis and perpendicular axis theorem will be helpful for us. And so these are the applications of these two theorems, which are very, very important from the examination point of view, and you can able to apply it over here. Although last time in the paper we have got the topic moment of inertia of the rod to have been calculated, and so that will be there. Similarly, for knowledge, we can, although these topics are not be there in the syllabus, so for your knowledge we can write the moment of inertia for other objects like hollow sphere and solid sphere. So one is hollow, another is solid. Similarly, hollow cylinder and solid cylinder, hollow and solid. So these formulas can also be written, and these formula can be applied wherever necessary. So for hollow cylinder, the formula is coming out to be moment of inertia is equal to mr square. For hollow it is mr square, while for solid solid mr square for hollow. For solid it is half mr square, while for hollow sphere it is 2 by 3 mr square, and for solid sphere it is 2 by 5 mr square. So moment of inertia for all the different objects can be measured like this way. So this is how all the moment of inertia of different objects starting from rod, ring, disc, sphere and cylinder, that we have written it out. Now how we can apply it on the numerical parts, so that part we are going to discuss now. So let us start with one example. For example, consider a numerical problem like this way. Three balls, numerical is 3 balls are being located at of masses 1 kg, 2 kg and 3 kg. This is your for 1 kg, 2 kg and 3 kg. They are located at the three corners of the triangle, of an equilateral triangle. So equilateral triangle means side is of 1 meter each, which has been given. So 1 meter each. So 1 meter each. So like this way. Now we have to measure the moment of inertia with respect to the centroid, that is G. How to calculate the moment of inertia with respect to the centroid? So centroid will be like this way. So this will be taken here. So that means we know the moment of inertia is equal to inertia is half is equal to m into r square, that is mass into distance from the axis of the rotation. Now since this is the axis from where with respect to which we are going to measure the moment of inertia, so the distance is required to be measured from this point and this point. So that is the point. So let us say the points, call them A, B and C, and this point is called as G. Now the problem, I think so you have understood the problem. The problem I will again repeat. A triangle is given, three masses are given of 1, 2 and 3 kgs, and then we have to find out the moment of inertia with respect to G, that is the centroid. And the triangle is an equilateral triangle and all the sides of 1 meter each are given. Now the problem is very, very easy. So first of all we have to measure the distances AG, BG or CG. That is the main problem. Once you find out the distance, then the formula will be written as m into r square, m2 into r square, m3 into r square, and that is the simple formula for measuring the moment of inertia. So that means the formula will be, which will be applied, will be equal to mass of A into AG square plus mass of B into BG square plus mass of C into CG square. So that is how easily we can able to measure the moment of inertia. Now main problem arises how to get the distance from the axis of the rotation. That is why to measure the value of AG, BG and CG. That is the main problem. So what is the main, how we can able to find it out? So we know that, so to understand that, again I will draw a triangle A, B and C. Now how to find out the centroid? Centroid is basically the point of the intersection of the three medians of the triangles. So this is the point of introit. Now we are given the three sides. Now let me explore it further. Now since they are given 1 meter each, so 1 meter and this is 1 meter. Once you draw the median, let us say this median, so this is half meter, this is half meter, and this is A, B and C. So that is how. Now we have to find the value of AD first. AD can be found out as under root of AB square minus BD square, that is equal to 1 square minus 1 by 2 square. So that is equal to 1 minus 1 by 4. That is under root of 3 by 4 or under root of 3 by 2. So that's the value of AD. Now we have to measure the centroid. So that is the point of G. This point and this point. Now we know each angle is of 60 degree. So what we will do, since this point of bisection will be taken, which will be intersected here, so this angle will be of 30 degree. Now in triangle ABD, we will apply a simple theorem, that is BD upon AG. BG is equal to cos of 30 degree. We know cos 30 is root 3 by 2. BD we know half. We have to find out the value of BG. These two get cancelled. So BG will be equal to 1 by root 3. Now once the value of BG is found out, we can find out AG is also similar way, 1 by root 3, and CG is also equal to 1 by root 3. Now we will apply the moment of inertia. Mass of A, 1 into 1 by root 3 whole square plus 2 into 1 by root 3 whole square plus 3 into 1 by root 3 whole square. So that is 1 by 3 plus 2 by 3 plus 3 by 3. That is 6 by 3. That is 2 kg meter square. So that is the final moment of inertia of the this problem which has been found out. So that's about one's problem. Next problem we will discuss in the next part.